Bean.
I'm Alex Baker.
I'm Kevin Lizama.
I'm David Turner.
And we're presenting our proposal for campus solar panels today. So I guess as an overview of what we're trying to accomplish here, we'd like to introduce renewable energy technology to Brigham Young University, Idaho, by introducing solar panels to add to the existing electrical engineering curriculum. And what we believe that that will do for the school is ultimately save us on utility costs in the long run, as well as provide a learning tool for students who are interested in going into the electrical engineering major with an emphasis in renewable energy and who are looking to do that as a future career. So with supervision, the students will be able to maintain the solar panels and will be able to learn about how they operate, and the maintenance of that would fall to the electrical engineering department as a project for the students for ongoing maintenance. We believe that we'll be able to develop a learning model through this as students are able to learn to provide for themselves and for their futures ultimately. But as we prepare for our future through learning about these solar panel technology, we'll be able to pass that knowledge on to our fellow students and teach one another, and we'll be able to grow personally as well as help each other grow. And what we hope that this will do is also to help set our university apart and help us to gain a reputation as someone who is interested in the future of energy, and attract students and faculty who are interested in these things as well. We also hope through this to set an example to the community and to the state of utilizing renewable energy sources to get the ball rolling toward a renewable energy future.
As Marcus was saying, when we were talking about deciding what to choose for the proposal, we talk about like all the pros and cons about this project and how we're gonna bring it up to the school. We thought about like the school as a very big icon for this city. We're in Rexburg and kind of a small town, so like if we can set an example, we can get something very big starting here. We searched that the time frame for this project, it wouldn't be that big. It is just between 3 and 5 months that we can get everything set up here on campus. But it also depends on the weather, just because Rexburg is not a very steady city with, like a city with steady weather. I mean, we talk about like what buildings will be, what are the most beneficial aspect for this project, and we decided that we were gonna search for the Austin building and the MC building as well. Ultimately, we decided to go with the MC building just because it had like a better location on campus where we will enjoy of a direct the sun will be pointing at it directly over there. So we also we searched and we found that the roof space in the MC was very available, and it was pretty easy to set up the solar panels. And then we were gonna start this project with this small amount of panels on the northwest corner of the MC. Everything else that we found about for this project was really a small budget, even though I mean it's not gonna be very cheap. But talking about like the whole campus idea of bringing this up and how we can start it, it was actually pretty easy to start with a small amount of money.
So if you guys have the slides up?
Yeah.
So
Yeah, I
if
have
you
them.
if you go to page 6, or slide 6, so we talked about, Kevin talked about how we were trying to decide between different buildings, and we narrowed it down at first to 2 buildings, the Austin building and the MC. So slide 6, that's the Austin building, that's the rooftop. And what we did is we actually simulated putting solar panels on top of that building. So if you see in the top, at the top of the picture, what's squared in, those are where the solar panels could go. And on the Austin, that's about the only spot it could go because of all the different obstructions throughout the rest of the roof. Can you see that?
Yeah.
Okay. So that's why we ultimately didn't go with the Austin building. You can, if you go to the next slide, slide 7, you can see more so what all the obstructions are. All those yellow spots, those are all the obstructions. So there's not very much space, but also there's more tree cover. It's not as accessible to the sun. Doesn't have as much direct sunlight. If you go to slide 8, you will see kind of an average daily energy output by month. That's for the Austin. So we'd still be able to get some benefit out of it, but it wouldn't be as much. Slide 9 is the MC. You can see that there's a lot more space in the MC. For the beginning of the project, the beginning stages, we would put the solar panels on the bottom left corner of the picture. That's the southwest corner of the building. There's a lot of sunlight. It's higher up than most of the buildings on campus, so it's very accessible. And if you go to slide 10, there are some obstructions, but not near as many, and they're not near as concentrated everywhere else on the building. And so if you go to slide 11, you'll see that we would get more energy output from the MC than we would the Austin. So ultimately, that's why we chose that. It's also accessible for the students, like Marcus talked about earlier, if students were able to go and help maintain them and learn about them, as well as the staff, the faculty, maintenance crew, and whatnot.
Sweet. So in slide 12, going over the budget, the total cost of the equipment is roughly about $750,000, if you want to go at that. The reason why this is so much is because the panels aren't really that cheap, and so if we were to find a supplier or any other type of dealership that could essentially give us a cut in ordering a large system, then it would be cheaper. And so on the slide it says that it's $600,000 through $750,000, and that's because of that dealership or that deal that we could get through someone who supplies it. And the reason that we have a payback period of 4 years is because as we get the system hooked up that has, say, 2,000 or more solar panels, then after a while this starts to cut into the cost. And after doing the math and everything else that was in our documents, we figured out that the payback period would be about 4 years. And so after that, you would start to make money back. And as you made money back, then that would be a worthwhile investment.
Just to cut in there as well, one other thing that we looked at as we were putting this proposal together were some of the green incentives that are offered by government, I guess, branches. And there are some at the state level as well as at the federal level, quite a big number of these. Unfortunately, looking into researching them would require some extensive effort. So as part of our proposal as well, we would dedicate some time into contacting these government agencies that do provide stipends for green initiatives. And the initial cost could go down dramatically based on that, and then our payback period would obviously be shorter as well, based on how much we were able to get via government incentives.
Yeah, that's true. I also was thinking, if you look at how much is actually spent on that, that's a lot of money. And to be able to make that much back in 4 years says a lot. all the numbers and things that we crunched to get this 4-year payback period came from a degree, or not a degree, a audit from BYU Idaho themselves that we found online. And so the numbers are accurate, and they're as true as what BYU Idaho did in their audit.
And I'm going to jump in again really quick as well. There are some, including the budget. The budget would increase just from overall increase of attendance as well. There are other small universities in California mostly, and also in Colorado, that have implemented some of these solar panels, these green initiatives, and it's attracted a lot of students and a lot of grants and everything like that to help relieve the burden of the budget of actually applying this. So there's financial gains to be had that we might not even see as of right now.
And kind of to piggyback back off of that as well, the dream is to use that money after the payback period that we would be saving on power to reinvest back into the green energy program that BYU Idaho will offer, as David was saying, to be able to attract some of this positive attention from prospective students, as well as from grants and programs and things of that nature. And any money saved that could be reinvested into the program could really, in a way, pay for itself. The program could ultimately, and pay for its own growth and sustaining itself.
Yeah, the Manwaring Center as well is one of the most power consumptuous buildings on campus as well. And so that's also why we chose the Manwaring Center, is because it would help pay off the most. And if you look at the whole campus, it's about 4 billion kilowatt hours a year. And just the Manwaring Center alone is almost, I would say, if I can remember right, is about 1/6 of that. And so having that much power supplied for that would be free in the long term would be able to, in reality, pay for other buildings to get the same. And that, like they were saying, is the goal of this proposal. So in conclusion, not only would students be able to learn from this, future students even, as they continue to pay off the charges and different expenses that solar panels would use to be implemented, they would be able to learn from that and then continue on throughout all the buildings and make improvements as year to year students come in and go. Not only that, but financial savings. That was the big part of this. BYU Idaho is green not only in electricity, but also in other power things as well, natural gas and water and all that. One thing that was mentioned earlier is the green savings, and that was a big part of it too, because every state has different benefits that will come by through this, especially through the power companies and those that use the electrical grid. And other than that, the proposal would be to basically do all this, so that's all that we have.
You guys have any questions?
No. That sounds good.
Hey. All right, you guys are up.
Okay. Do you have our slides? Were you able to find those?
I'll find them. Yeah,
Okay. Okay, I think we'll go ahead and start. So I'm Spencer Palmer.
I'm Bit.
And so our presentation today is on a replacement for iLearn. So yeah, we'll be talking about learning management systems and a proposed replacement for the current iLearn system. So on the second slide is our executive summary, and kind of our goals with this is more direct online collaboration between students. One of the things we'd like to talk about is a built-in chat system that allows real-time discussion to take place between students on different assignments. We'll also talk a little bit about architecture and planning that we can implement in this proposal. On the third slide is our introduction. So we're talking about, with iLearn, we're talking about a learning management system, often referred to as an LMS. And this is the basic system that students and teachers use for online learning. It's kind of the classroom where teachers can post assignments, students can collaborate and view their grades and then submit their work. There are a lot of online or learning management systems in use today. A lot of them aren't very student-centric. They're more designed for the teacher to be able to manage the course and hand out coursework. So that's one thing that we'd like to fix, is we'd like to be more focused on students and be more mindful and friendly to student needs. On this slide, there's a survey of what different users of LMS systems, what they desire. The thing that they like most is increased functionality. And so we're hoping with a chat system and collaboration tools that we can provide that functionality that students would like. They'll make their learning experience better. So I guess the problem is that, you know, the classroom is transitioning from a traditional classroom setting to being online. And on slide 4, there's a chart that shows how online enrollment has steadily gone up. And a lot of students really struggle, especially since students are going to school that purely take online classes. They don't have the help that students get in the traditional classroom setting. You know, the instructor's not there. They're not surrounded by peers. And so as online enrollment goes up, a lot of students struggle and they don't reach their potential because they're not able to get the help that they need. And with our system, we'd like to implement a chat system that makes it a lot easier for instructors and students to communicate when a student needs help. So you can see who's online at that moment, and you can talk about different assignments and get the help that you need. So our objectives is we'd like to build a chat system so that students can communicate and they can see who's currently viewing assignments that they're working on. So if a student is working on assignment, he'll have, on his screen, he'll be able to see what other students are currently viewing that page, and he would be able to chat with them and send a message. Or, if he gets stuck, he could go back and scroll through the chats that have happened earlier on that page, and you can see what other questions were asked, what other students talked about, and he can get help that he needs. We also think that having a built-in chat system will help with collaboration on assignments, and we'd like to integrate a video system as well. So third-party video systems won't be necessary. Students, if there's an assignment that they need to work face-to-face, they can just start a video chat right there. They can work. Any conversation that they have can be saved, and when they go back to that. The main thing is, we want to provide this not just so students can communicate, but so instructors can communicate better with the students on those assignments and the pages where they're found. So on slide 5, it kind of is our plan, and we'd like to start by researching other chat systems that have been implemented in other places. Social media does really well at providing communication and making it easily accessible and natural. So we'd like to research and look into that a little bit. After that, we'd like to diagram and plan out the core functionality of our system using UML 2.0 diagramming, and really discuss and plan the core functionality. A big part of it will be user interface. People tend to react better in a user interface that they feel comfortable with. And so we'd like to do a lot of testing. And one of the first things we'd like to implement is a user interface so we can get feedback and we can build something that students can navigate their way around and feel comfortable with. After that, we can start working on the core functionality, and we'd like to employ the Scrum development methodology. And in Scrum, you do short, I guess, sprints. And so these sprints will last a few weeks. And at the end of each sprint, we can meet as a team and with the stakeholders who are involved, and we can see if we achieved our task. If not, we can decide what steps we need to achieve that. And then on a daily basis, we'll do our daily meetings as a group to see where we're at. But the main thing is we want to keep stakeholders involved and let them know what we're doing. After we've got that built, we'll do testing before we implement the system. On slide 7 is kind of the plan. So if we're able to start in December, we figure that by May we'd be able to have it implemented and everything in place. And that brings us to slide 8, which is the budget.
Okay. So I want to talk about the budget in detail, and I would like to start by looking at how the cost for the project is mainly labor expenses. Next slide, slide 9. Okay. So the cost for this project is mainly labor expenses because all other infrastructures such as servers, computers, and softwares are already available at BYU Idaho. Next slide. So here's a photo of IT server room at BYUI, and as you can see, infrastructures at BYUI is great. Next slide. So as for labor expenses, BYUI HR department states that hourly minimum wage for BYU Idaho student employees have been increased in 2015, and suggested pay rates for leads and specialists requiring prior education, experience, and certification is 8.75 per hour. But we would say that we are more than specialists because this project requires highly specialized skills, and suggested pay rates for coordinators requiring highly specialized skills is 9.60. And we expect to get paid for 10 per hour for 8 hours per day for 5 days per week. Next slide. So the time period for the project should be 6 months, and 5 days a week and 8 hours per day will cost about approximately $400 per week and $1,600 per month per person, and that's about $9,600 for 6 months per person. And assuming there will be about 6 people working on the project, it will cost about $57,600. Next slide. Now I want to talk about personnel and qualifications. Bitkim, that's me. I'm a junior computer science major at BYUI. I like everything about the web. I have plenty of experience in developing web application and websites using HTML, PHP, Ajax, and MySQL. I'm capable of both front end and back end. Spencer Palmer, a web design development major at BYUI. He has experience in web application development. Matt Bigley is a software engineer major at BYUI. Next slide. We also need to hire additional front-end developer, a back-end developer, and a supervisor who has a vast experience in leading a big project. Next slide. For supervisor, I'm suggesting Scott Burton, a computer science professor at BYUI. He has a vast experience in various areas. He also has experience in architecture and development of web applications. He also has leadership, consulting, and training experiences with faculty and staff. Next slide. And as for facilities and equipment, we would need desktop computers, and we will also need dual monitors for each one of us in order to increase the efficiency of our work. We also need to we also need our own workroom that has a whiteboard on the wall so that we can collaborate and share ideas, and it also has to be noise free in order for us to concentrate. Next slide. So learning management systems have been widely adopted by higher education institutions over a decade, and these systems offer students and teachers the ability to interact with video conferencing, threaded discussions, and forums. However, studies show that current LMS users most often cited a need for more functionality and marked current system unsatisfactory. So with our improved LMS, students will be able to collaborate with other students and teachers in a manner that that feels more natural and unforced. And that's it.
Sweet.
Okay. Well done.
That was good.
Good. Well,
Yeah.
I'll get this uploaded and send you the link.
Okay, sweet. Are you gonna post the slides? Will you? Because just one of us needs to submit the actual thing, the video.
Oh, okay. Yeah, I'll post the slides on the YouTube page, comments, or whatever.
Okay, sounds good.
Okay, all right. Have a good night, guys.
Awesome. Thanks, guys.